Okay, so hopefully you had a chance to look through this example, so let's see how you did. So notice on this one, the denominator is not factored. So we're going to want to start by factoring that denominator. So since there's no greatest common factor, I just want to figure out the binomial that multiplies, the two binomials that multiply to give you that. So the first term is x squared, so the first term in my binomials would have to be x and x. And then I need factors of 6 that will subtract to a -1 in the middle. So I know that 3 and 2 will subtract to 1. And since I want a -1 in the middle, I want the 3 to be negative and the 2 to be positive. Okay, so now if I go through and find all my information for the denominator, or for the domain, I want to look at the denominator. And the denominator tells me that x cannot be 3 and x cannot be -2. There are no common factors between the numerator and the denominator, so that means there are no wholes, which means that both factors of that denominator are vertical asymptotes. So my vertical asymptotes are x equal to 3 and x equal to -2. Now, if we look at the leading term on the numerator and the denominator, I'm going to have 6 over x squared. So if I look back at the original function, x squared was my leading term in the denominator, and 6 was my only term in the numerator. So I have more x's in the denominator than my numerator, which means that my horizontal asymptote is y equal to 0. For the x-intercept, we set the numerator equal to 0, and when I do that, I get 6 is equal to 0, which makes no sense. That's not true. So that means that what I'm trying to find does not exist. So there are no x-intercepts. For the y-intercept, I want to replace all of those x's in the original function with 0. So I get 6 over -6, which gives me a y-intercept of 0, -1. So we're ready to start graphing. So I want to sketch out my horizontal asymptote, which is on the x-axis, put in my vertical asymptotes at 3, and I also have one at -2. And the only point that I have is 0, -1 for the y-intercept. So like the last one, there's going to be a lot of testing. So we're just going to start testing from left to right. So if I start on the far left, I've got a vertical asymptote here at -2. So I want to pick some number to the left of -2. So I'll use x equal to -3. And if I plug -3 into that function, I'm going to have 6 over -3 minus 3 is -6, and -3 plus 2 is -1. So I'm plugging -6 into this factored form of my function just because the arithmetic is easier. So that gives me 6 over 6, which gives me a y value of 1. So if I plot -3, 1, I know now that that branch is above the x-axis. The next place I want to test is in between the vertical asymptote and my y-intercept. So I want to test in between -2 and 0. So if I do that, I'm going to pick something in between there like -1. So that's going to give me, when I plug it into the original function, 6 over -1 minus 3 is -4, and -1 plus 2 is 1. So I get -6/4 or -3/2 for that y value. So if I plot -1, -3/2. That's there below my, excuse me, my x-axis, which tells me that, I'm sorry, I gotta move that a little bit, I apologize. -3/2 is -1.5. This was -1. So -3/2 would be a little bit further down than I had it. Okay, so below the x-axis means now that I know my branch in between there is going to have to be below the x-axis. So I'll draw it like that for now. Next spot we're going to move to is in between the y-intercept and this vertical asymptote. So that means in between 0 and 3. So I'll pick x equal to, I'll pick 2. So if I plug in 2 into that original function, I'm going to have 6 over 2 minus 3 is -1. 2 plus 2 is 4. So that's also going to give me -3/2. So at 2, I don't know why I didn't pick 1, but if I plot that point at 2, -3/2, it's there. So this branch is also below. So my branch would look like this. It's probably a little flatter here like that, but I don't care. You'll get the idea as long as you have the right shape. I'm not going to pick on you. Okay, now the last space we need to test is over here on the far right, in between that vertical asymptote and infinity. So something to the right of 3. So if I pick x equal to 4 and plug it into the original function, I get 6 over 4 minus 3 is 1, and 4 plus 2 is 6. So 6 over 6 is equal to 1. So if I plot for 1, it tells me that that branch is also above the x-axis. So there's what my curve looks like. I hope that you made it most of the way through, or if not all the way through, without making any mistakes. And again, I think I showed you probably the harder of the problems with all of that testing. So if you could do these examples, I think you're going to be just fine for the homework and the upcoming quizzes and exams. Please feel free to email me if you have any questions about these videos or any of the homework problems.